All right, greetings everyone, and welcome to another exciting episode of IT Pro TV. I'm your host, Daniel Lowry, and in today's episode, that's right, we're continuing on with our Python programming series. Hopefully you're getting a lot of enjoyment out of that. Joining us back in the studio again today is our mentor in that endeavor. That is Justin Dennison. Justin, welcome back to the show, sir. How you doing?
I'm doing great. I'm really excited to be back. We're down to our final core data structure, tuples.
We'll say no more.
Yeah, I know.
We
right?
should just end the show right there, right?
And we're done. First off, there is some contention. Is it tuples or tuples? It's up in the air. Whatever you like.
Potato, potato.
Potato, potato. You know, I've heard tuples, but you know, when I say quadruple or but then when you say quintuple, I don't know. So you make your own decisions about how to pronounce it. It's up in the air.
Well, that being said, now that we've had a little fun with the word here, it is a strange word. What exactly is a tuple? I mean, we're working in Python. Maybe is this specific to Python? Do other programming languages use this, or how does that work?
There are some programming languages that have tuples. They're typically those more esoteric ones. I think Python is the most mainstream one that I know of. I'm not saying that there aren't others or some hidden type things nested away in other languages that implement tuples. So tuples are kind of like immutable relationships. So we had those dictionaries that can map, but those were mutable. With tuples, I can create effectively an immutable list that is used for establishing relationships. Like if I had a tuple that represented a person, the first element may be the first name, second element may be the last name, and then the third element would be their age. So that would be a relationship between those three pieces of information, and I don't want that to change. So tuples are a great way to bind all of those together in a nice little container that I don't have to worry about people changing, because they are immutable, very much like strings. So I had, the relationships with dictionaries which were immutable, so they corresponded kind of to lists. But then, strings are immutable. I need some way to bind these things and not have that mutability become an issue. So tuples kind of fill that role.
So they're kind of the yin to the yang of a dictionary, right? Where the dictionary says, well, you can make these associations anything you would like them to be with a tuple or a tuple, however you like it. Once you create the association, that is it. It is lock solid. It is not changing.
Exactly, and that's how I like to think of them. There are some, more stringent reasons for having tuples, and we'll see a couple of different uses. I typically have some standard uses for tuples, but I've seen people implement them as like discrete pieces of data or ways to switch things around or all kinds of stuff. But they have some very interesting properties that allow us to shorten our code, make it a little more concise, and sometimes once you figure out how tuples work, a little more readable. Cool. So I think the best thing to do is just take a look in the Python shell about what is a tuple? How would I define a tuple? How do I know if it's a tuple? Some common usages are to return multiple values from a function or to switch variable values. So there are some algorithms where I need to do something to variables and then switch their values and then kind of repeat that until some condition is met. But the most often thing that I use them for is to be able to return multiple values outside of a dictionary from a function. So I can say I know the first value is always the name, the second value is always the age, the third value is always the city where they were born. And we'll look at a couple of functions that do that. We'll implement our own. But before we do that, we need to look at tuples, right? So I need to look at tuple 1. And tuples are surrounded in parentheses. They work kind of like lists, but list, I could make an empty list like this. But if I try that with a tuple, okay, and then I go type, tuple 1, that is a tuple. So, okay, I have an empty tuple, but I already said they're immutable. Like, well, I can't change that. If I want to say tuple 1 0, right? I'm using some of the things I know from list, equals 1. It goes, hey, can't do that. I get a type error. It says does not support assignment. So, okay, I don't know why we need an empty tuple, but the logical progression, and here's where the hiccup for a lot of people happen, is I'm going to reassign tuple 1 to something a little more useful. I need a single element in there, and it's just the number 1, or let's go with 10. And I'm like, okay, I have a tuple, and let's make sure it's a tuple. Well, that was unexpected. But if I use empty parentheses, I get a tuple. But if I use a single value in there, I get an whatever that value is. This was an integer. It could have been a string. So this is the first big hiccup when people use tuples. This is a weird syntax to me. If I actually want this to be a tuple, I need this to be a trailing comma. So then if I go type of tuple 1, I do get a tuple. And I will tell you, I can't tell you the countless number of times where I'm like, well, why can't I can't access an element. That's not working right. I'm getting weird type errors, and it's because I thought I was creating a tuple when in fact I was just creating an integer or a string or something of that nature. So I get this unpredictable behavior. It's very important to realize that tuples have this is fairly unintuitive as far as the Python world goes for me when I look at the broad scope of what we've covered thus far. So tuples are not limited to single elements. I can have a quadruple, right? So let's just actually call it a quad. And I could say 1, 2, caret, and some name, right? I've created an association between this packet of data. So I now have quad, and I can confirm with the type function that it is in fact a tuple. Tuples provide a wonderful way, and we use this in functions, to do something called unpacking. So I can actually utilize Python to take this group of data and assign it to variables all in one line. So I can say A, B, C, D equals quad, and it will actually unpack those for me. So if I look at A, that was the first element in a tuple, in that tuple in particular. B was the second, C was the third, and D was the fourth. But there's, we have to be careful because we have to understand tuples come with a fixed length. So if I went A, B, C, D, or let's just leave off the D, and I say quad, I will actually get what's called a value error. It'll say, hey, you got too many values to unpack. I don't know what to assign to A, what to assign to B, what to assign to C. What do you want me to do? So when you see value errors, that means you're trying to assign like 3 variables to 4 values, or 5 values to only 2 variables, something of that nature. So
there needs to be a one-to-one mapping with your tuple and your variables that you're assigning.
Exactly.
Gotcha.
Exactly. Now, what really comes out great is because I have this unpacking ability, when I return these to functions, I can make a function call, and if I know that I'm getting a first name and a last name separately, I can assign those separately in variables. First, comma, last equals get names, something of that nature. We'll take a look at that. But other than that, we get all of the collection methods that we normally have. How would I access? Let's look at this quad. If I didn't want to change this, I just wanted to grab this one value, I can say, hey, give me the 0th element. They're still 0 based. If I wanted the second element, which would be indexed 1, I now have that association that I do in lists and in strings, but now a tuple allows me an immutable structure that I can put any data I want. Strings, numbers, other tuples, other dictionaries, all kinds of weird nested structures.
Do tuples show us the mappings kind of like the dictionaries did, where in dictionaries we had 1 and it would have the number 1, right? And 2 and have the number 2, and we created those associations. We could see them as we printed that out. Does a tuple do that same kind of function?
No, it's implied very much like a list. This first thing is the 0th element. The next thing is the first element. The next thing is the third element. Did I say third twice? I'm sorry if I did. I think I meant 0, 1, 2. So sorry about that. But really what we're doing is, let's say I wanted to, here's a person, right? I have a variable called a person. I want to create an association, and I'm going to create a tuple that has a very specific structure. First name, last name, age. Okay? Just like we were talking about. So, Jim, John, 21. So now this person is this tuple. These kind of imply a relationship, but they have a specific order. They keep that order, unlike dictionaries, but like lists or strings. So now I have this kind of deterministic behavior where I can go, the first thing from a person like tuple is going to be the first name. The second thing is going to be the second name. And then I can say first name, comma, last name, comma, age equals person. And that's a quick way to start peeling apart these data pieces. So we get this little extra functionality, but I wonder what else do you think these could do? We've had this intuitive feel. This is a collection. So what are your thoughts, Daniel?
Yeah, my thoughts are is if I can do all the other cool collections on the other types that we looked at, that I should be able to run those on tuples as well.
Let's find out.
Let's do it.
Let's find out. So can I get the length of a tuple? And I can, in fact, get the length of a tuple. That tells me how many elements are in there. Now, for some of the mutable structures, right, like lists or dictionaries, these properties may change. But with these immutable properties, for this particular tuple, unless I reassign the variable, I will always get 3. I wonder if I can do this membership operator, like, is Jim in person? So is the name Jim in person? It is. Is Steve in person? And it is not. So I get that membership operator just like I do with lists. I wonder, we saw strings and lists had that repetition operator where I can get right over and over and over again. I wonder if that occurs also. So if I go person times 3, and I do, and here's what's, just like strings, the original person didn't change. I actually get a new copy of the tuple that says, I'm going to give you the copy, or the tuple copied 3 times into another tuple.
Is that basically like a dynamic copy where you say, I have this tuple person and I want to multiply it by 3 and give me 3 iterations of it, and then it creates that as, like I said, kind of dynamically, where once it's done and it outputs it, then it deletes it and it's gone?
So unless I actually physically assign it to something like person triple, right, is person times 3, unless I do that, then yes, once it's output, like, there's no other need for it. It may remain in memory for a little while behind the scenes, but you don't have access to it, so it will be what's called garbage collected very, very quickly.
Now, Justin, one of the cool features that we've seen so far with many of the other types of collections that we used is slicing. Slicing was very, very helpful for us and the other collections. Can we use slicing here with tuples?
Well, intuitively, if I'm looking at this from a beginning aspect, when I first saw tuples, I was like, well, I wonder if I can, I asked the same question. I wonder if I can slice tuples. I think there's only one way to find out. I could go on the internet, but with the Python shell, I could say, okay, give me from 0 to the first thing, and it does give me a slice. But how does it return the slice? And that's a key difference for all of these slicing operations. If I slice a tuple, I get a tuple back. If I slice a list, I get a list back. If I slice a string, I get a string back. So the slice actually gives me the data type, the thing, the entity, in the same form that it originally was. I wonder if I can do that skip thing. So maybe I should use person triple for that. So go through the entire thing and give me every third. Gotcha. So start at 0, 1, 2, give me that one, 1, 2, give me that one. So I can skip through here. What if I wanted to start at 1 and go through there? Then I'll get John, John, John. And then likewise, I can do 2. So the slicing is very important. I can start to extract these. And now that I have a tuple, I could even do something like this. A, B, C equals person triple 2 colon colon 3, right? So this means start at 2. If I put nothing here, just as a quick reminder, this means go to the very end and step by 3. And now A has 21, B has 21, C has 21. So I can split those out into variables very quickly.
Now, Justin, as this seems like basically, again, like kind of with the other different types of collections that we've used, it's basically a list of things. And I know, I'm starting to assume with Python a lot here, that usually if I have a list, I can iterate through those lists when necessary. Is that possible?
There's only one way to find out. So let's just use, standard collection. Let's say 4 element in person triple print element. And it does in fact iterate very much like a list. So I can almost think of a tuple as a fixed length list, which is interesting because in other programming languages, if you've ever programmed in Java or C, when you make an array, which effectively is what a list is, it's fixed in length. Like you can't change it. You have to make a new copy and do stuff like that. So this takes a little different paradigm. Lists, which are commonly used, are dynamic. They can change in size. Tuples, on the other hand, are fixed and behave very much like an array as we would think of them in other languages. But really where the power comes from tuples, and in my view, this is something that makes sense to me a lot, is in functions, right? So if we hop over to our little, our little script here, tuples.py, I got my shebang here, I got my main method, but I'm going to create a function, and I'm going to call it divMod. Okay, so here I'm going to explain what the function is going to do. It's going to take 2 numbers, so A and B are numbers. So just to comment that out, A, B are numbers. I'm going to find the division of A divided by B, right? Or better put, the quotient. And then I'm going to find the remainder. And Daniel, do you remember right offhand how I can find that remainder?
Yeah, it had to do with floating point integers, right? Or we had to use if I can remember it correctly. Oh man, I can't remember. It was the percent sign.
Yes,
right? Yeah.
You got it.
Yes.
Right. All right. So I can actually do a %B, and that will return the remainder of A divided by B. And we'll see how that works. And then I want to return the quotient and the remainder together. And normally, if I wanted to do that, I would have to put them in a dictionary and name them. But I know for something this simple, I just want to return the quotient, the remainder, always. So A and B are numbers. I need to address that first. If the type of A is equal to int and type of B is equal to int, and these are integer numbers, then I'm going to do this part here. And I'm going to return. Otherwise, return. And there's this, I want to introduce something new. I'm actually going to return nothing. Okay, so this allows me to interact with this method and go, hey, you didn't hold up your end of the bargain, so I'm not going to give you anything back. This is a key word in Python that you'll see a lot of functions will have a return type of none. And if they fail, you can say, hey, try this. If this is none, then we need to change course a little bit because something went wrong. So this is some basic error handling. Not necessarily the most robust, but it's
functional.
Available. Yeah. So if I want the quotient, and that's just going to be A divided by B, and then I want the remainder, that's A%B, and then finally I want to return A, quotient, comma, remainder. So what do you notice about this, Dan? In the shell, I was defining tuples in a very specific way, but what do you notice about this?
In what way?
So this return function, typically when I was creating tuples, what did I say were required?
Let's see here for requirements. Again, I'm not quite following. I don't want to say the wrong thing or lead you down the wrong path.
No, it's totally fine. So if I look back in the shell, all of these things were surrounded in parentheses, but I'm not surrounding these in parentheses. When I return these, if I separate things by a comma, then it kind of implies that this is a tuple. I can put parentheses around these if I want to. And that'll ensure that I understand. It's a reminder for me. It's kind of self-documents. Hey, this is a tuple. So I have this thing called div mod, so division and modulus of A and B, and it returns a tuple with the quotient and the remainder. So if I have, let's say, number 1 equals 4, and number 2 equals, your favorite number was 9, you said 9 a little?
It's a lovely number.
It is a lovely number.
Very aesthetic, the rounding of it.
Yeah, yeah.
It's prime.
Is it prime?
I think it is, right?
It's odd.
It is odd. Is it prime? Yeah.
It's 3 by 3, right? 3 times 3?
What? 3
Can't be
times 3? Oh, it is 3 times 3. I told you, I'm not good at math.
It seems like 9 should be prime.
It seems like it should.
Yeah,
Intuitively,
you're
my
like
brain
1,
says
3,
9
5,
is prime.
7. You're like 9's gotta be.
Yeah.
And it's like, nope, 9's not. And you're like, hold on a second. So if I have these two numbers and I want, you know, the div or modulus or remainder, I'm just choosing variable names, then I can say, hey, div mod number 1, number 2. Okay? Now, wonder what this is going to do. It looks like it should unpack. Let's just print div and print the remainder. So clear and tuples, and it does in fact unpack these. So it assigns div to the division, 4 divided by 9. Well, 9 doesn't go into 4 evenly at all, so divides evenly 0 times. And then what's the leftover? Well, there's 4 left over because it was never divided. If I were to switch these in order, though, we will see that that in fact does change. 4 goes into 9 2 times with a remainder of 1. And this is a great way to kind of index things, you know, skip over certain ones, get this information back all at once instead of going, okay, I need to divide, then find the remainder. But what happens if I just say, you know, some horrible variable name like D? What happens if I do that and I print here? Then I get back a different data type. So that's something I have to be aware of. That unpacking can actually change that because if I look at the type of D, it is in fact a tuple. But if I go back to div remainder and do div mod, number 1, number 2, and I print the type of div, and I print the type of remainder, then those are actually integers. So they're the embedded data that we have. So that's great, right? Now, I will be completely honest. We actually just implemented a function that's already in Python.
So you created a function that is completely unnecessary.
Yeah. So completed. If you want this functionality, you don't have to write this. Div mod is actually in the standard library, and we'll probably have more robust error checking than we do here. But it does exactly the same thing. It returns a tuple with the quotient and the remainder. and you give it 2 integers.
You know, I should have known, because when you started typing divmod, it tried to autocomplete it for you. And I assumed it was because you were working with this earlier and it was kind of remembering that. But now I know why, because it actually exists inside of Python as a function.
Yeah. So I think it's really good to see that, you know, sometimes these Python functions that we're using, they seem like magic, but as we've learned more of these, they're not actually that magical. They're pretty straightforward, and they're just there to be conveniences. But maybe we can change this div mod, and instead of taking the 2 numbers separately, what if we give the numbers as a tuple, and then we make assumptions behind the scenes, right? It comes as a tuple as the first divided by the second. So I would like to compare those, and I think that'll give us a good idea of how tuples can be used to pass around these chunks of data.
Yeah, this will be interesting. Let's see it.
So I'm going to name this a little differently so it doesn't do that weird autocomplete thing. So I'm going to say tuple div mod, and this is going to take my pair tuple, right? So pair tuple is going to contain the first and second numbers. Okay, so I'm going to pass this in as a tuple. So first off, I need to make sure pair tuple is a tuple. If type of pair tuple equals not tuple, that's something else.
Completely different.
Completely different. Then now I know that I can do the unpacking that I want. And in particular, this is a special type. This is a you know, 2 things within a tuple. And I can say, okay, first, second equals pair tuple. And then I can say div equals first divided by second, and remainder equals first mod second, and then return div comma remainder, else return none, just so you can say, hey, that's not what's supposed to happen. And I could even add a print statement, or as I get further into this, I could throw errors and break stuff. But you know, even without this if else, right? What's really crazy is I'm going to do something. I'm going to say print. Look here, okay? So I'm going to give this a tuple. We'll get the same output. I'm going to comment this out just so we can focus on the appropriate output. So here's my pair, and let's go with 4 and 7. So there's my pair tuple, and then I want div remain equal to tuple div mod, hand it my pair, and I should get that back, but it's going to hit this return statement right here. But I have a print statement down here. So let's see what happens, because I'm like, okay, I always want to print this output. So I'm going to print div and print remainder, and this is going to unpack, so these should be integers. And then I'm going to run this, and that's kind of odd. All right, I did get print div print remainder, except this didn't print.
The look here.
Yeah, the look here. I always want this to say, hey, look here, I'm doing something. I wonder why that didn't print.
Is it because of the return statement?
Daniel, you always make me happy. You're like, I think it's probably because you're absolutely correct. As soon as I hit a return statement in a function, that function stops. I get nothing below that. And actually, if we were using a full-blown IDE, it would flag this as unreachable. It will actually say, hey, you might want to take this out because this is never going to run. But it's good to know that as soon as you hit a return statement within a function, that function spits out and it stops. So,
Wow.
yeah.
So we'd have to move that. If we wanted it to do that, we'd have to actually put it well, I guess before or after our return statement, right? Or, yeah, before our return statement.
Before our return statements. Before any return statement is possible to be reached. Yep.
Cool.
So a little extra on functions, but notice I've been able to write effectively the same function, but here this had to take 2 parameters. Here this took a pairing, a chunk of data that then I unpacked and did something with. And really what I could do is say, hey, this always takes a tuple, but what if I gave it a tuple of 2, 3, or 4, and then I could say, okay, if the tuple is length 2, do this. If it's length 3, do a different thing. If it's length 4, do a different thing. So then I can really generalize those functions, and I know that people are always going to give me a tuple that I can always unpack in very particular ways. Very, very powerful.
Yeah, that is very, very cool, man. So obviously, tuples can become an extreme convenience factor for us when we have a certain amount of variable data that we want to work with, and if we want to change that, and it keeps us from having to write super lengthy amounts of code to make that happen.
Absolutely. So I use tuple unpacking, and function returns are kind of my main things that I use tuples for. You may find a multitude of use for tuples as well, but it's good to know that some built-in functions will return a tuple by default, and you have to be like, okay, well, why is this not working like I thought it was going to? Or, hey, I can do this weird comma, and it unpacks these variables. Crazy stuff.
Yeah.
But I think that'll get us ready to utilize these functions appropriately.
Very cool, Justin. Tuples, obviously, we need to dive into those, get a hold of them, because as we've seen, they can be very useful inside of our code. You never know when a tuple might be just your life preserver that you need to get that code working exactly how you want and be a whole lot more efficient and effective. Justin, we thank you for stopping by and explaining tuples to us, even though it's a funny word and enjoyable to say, or more enjoyable to use in our Python programs. That being said, looks like we've wrapped up yet another great episode. Hopefully you guys have enjoyed it and got something out of it. We're going to go ahead and sign off for IT Pro TV. I've been your host, Daniel Lowry.
And I'm Justin Dennison.
And we'll see you next time.